Okay, welcome to 9.2 Factoring the GCF. So we're going to learn how to factor an expression using the greatest common factor. So you found the greatest common factor before, and that's not just any two numbers or any numbers that go into two numbers. It's the biggest number that goes into two numbers. Okay, so the only number that I can come up with that goes into both of these would be 5. 5 goes into 15, and it goes into 20. Okay, in 78 and 27, I'm going to try to find the greatest common factor. And if you know the little trick to seeing if a 3 can go into a number, you actually add up the digits. So 7 plus 8 would be 15, and 3 does go into 15. 7 plus 2 would be 9, and 3 does go into 9. So I know that 3 is a factor that can go in there, into both of those. But how do I know if it's the biggest one? Okay, and you can be guessing and checking on your calculator, but if I do 3 and I put it into 78, it goes 26 times, and 3 into 20 goes 9 times. If another number can go into these new numbers, then that we still haven't found the greatest common factor. So the only number that I can think of that goes into 9 is 3. Does 3 go into 26? Well, let's add up the digits. 6 plus 2 is 8. 3 does not go into 8. So this is the greatest common factor. I can't go any further with that. Okay, what about this? What about once we get some letters in here? Well, we're going to find out how to do that in a moment. But first, let's see if we can just figure out the greatest common factor between 12 and 18. Well, I know 2 goes in there. Okay, but if I put 2 in there, this would become 6 and 9. Well, I can keep going, right? There's a number that goes into both 6 and 9. 3 goes into both of those. And this would become 2 and 3. And all this guessing and checking can occur, like I said, on your calculator. So actually my greatest common factor for this one's going to be 6. 6 goes into 12 and 6 goes into 18. You don't have to go this long way if you can think of already the biggest number that goes into both. I just wanted to show you how to break it down if it turns out that you didn't necessarily find the biggest. Because sometimes the biggest you can think of right offhand is 2, and then you have to keep going to see if anything else goes in there. But the biggest or the greatest common factor for this one's 6. All right, so how are we going to deal with those x's? Let's come down here. Okay, to find the greatest common factor for two monomials, and monomials are just these single terms here, find the GCF, so the greatest common factor, of the given number. So here we go, 12 and 18. Well, we already did that up here. We already found out that it's 6. Go ahead and put that in there. Now, do all the terms have the same variable? Okay, so we're looking, do they all have the same letter? If so, we can pull out that as well. So they both have an x, so I'll write that down there. And then, what is the smallest exponent? Of that variable. So looking at this, if there's nothing there, then the exponent is 1. Okay, so between 2 and 1, 1 is the smaller one. So 1 is the smallest exponent. Now we're going to put it all together. I have 6x to the power of 1, and I can just simplify that whole thing into the term 6x, because we actually don't need the 1 right there. So this is just going to become 6x. Okay, so this is leading into being able to factor this binomial in just a moment. But let's practice this with these problems here. So what is the biggest number that goes into both 39 and 18? Well, the biggest number that goes into both of them would be 3. And then do we have a common variable, so the same letter in both of them? Well, we have an x here, but we don't have an x here. So 3 is going to be the GCF in this A. All right, what is the biggest number that goes into 46 and 24? I'm going to pause for a moment, you think about it. Okay, so we get 2, and then is there a common letter? Well, there is. There's an x, and then the greatest exponent, well, there's a 1 on this x, and there's a 2 on this x, so we're just going to leave it as 1 on this x. Okay, how about You pause the video and give this one a try and then rejoin when you're ready. Okay, hopefully you've come up with something here. So if I pull out the greatest common factor between the numbers here, I come up with 5. There's an x in both, so I'm going to put down my x. And then the smallest exponent is 2. There we go. All right, now that we've practiced this, let's get into actually factoring out a GCF in a binomial. See, there's 2 terms, so it's a binomial. Okay, write the GCF in front of a set of parentheses. Okay, so let's go ahead and do that step. So we have 18x and 12x. So what's our greatest common factor with 18 and 12? We did this above. It was 6, and then we pulled out an x, so 6x. Okay, determine what you would have to have in the parentheses in order to distribute to the original problem. So how do we do that? Well, what we're actually doing is we're dividing the original by the GCF. Okay, so I'm just going to take my original binomial here, and I'm going to divide by 6x, both terms, and see what I come up with. Okay, so 6 goes into 18 3 times, and then you have to remember your law of exponents here, but you're actually going to subtract your exponents to divide these x's. So 2 minus 1 is just going to be x to the power of 1, so I'm not going to put anything there. And then 6 goes into 12 2 times, and x over x is just going to cancel out to 1, or if you think of it like that, we subtract 1 minus 1, and we get x to the power of 0, which is also still 1. But anything over itself just cancels out. So there we go. And then last step here, bring down the original sign. So my final answer on this one, now that I've completely factored this, is 6x times the quantity of 3x plus 2. Okay, we're going to give some problems a try down here. Be sure to pause, rewind, do what you need to do so it makes sense to you. You can watch these steps again to see where I'm getting everything as well. All right, so I'm going to pull out a GCF. The biggest number that goes into both of these is 9. I do not have an x on both of them, so that means that I can't pull out an x. And then I'm going to divide both of these by 9. 9 goes into 36 4 times, and 9 goes into 45, negative 45, negative 5 times. There we go, that one's factored. All right, here I see that I have both number and an x on both of them, so I am going to be able to pull out an x this time. The biggest number that goes into both of these is 2. I'm going to pull out my x, and I'm going to set up my parentheses, like this, and I'm going to divide each term by 2x. See what I come up with. All right, 24 divided by 2 is 12. X squared divided by x is x. And then I see that I have a positive here, so 46 divided by 2x, I'm going to need to make my parentheses a little wider here. I get 23, and then the x's just cancel out. So there we go. Now to check these, you can just distribute that 9 back in there and make sure that it's coming up with what you want it to come up with. So 9 times 4x would be 36x. 9 times negative 5 would be negative 45. Same here. 2x times 12x would be 24x squared. 2x times 23 would be 46. Okay, what is the biggest number that goes into 28 and 91? The biggest number would be 7. There is an x in both, so I'm going to pull out an x, and then I need the smallest exponent. The smallest exponent is 2. There we go. There's our GCF, and now we need to divide that in to each term and see what we have. All right, so 28 divided by 7 is 4. And then we're going to subtract our exponents. 3 minus 2 gives me an exponent of just 1, so x to the power of 1. And then I have a minus here, so I'll make this minus down here. 91 divided by 7 is 13, and my x squareds just cancel out. And of course, this time I left plenty of room. I don't need that much. Okay, so you can always multiply this back in. 7 times 4 is going to be 28, and x squared times x will be x to the third, because I'm going to add those exponents this time. Then 7x squared times negative 13, my 13 times 7 does equal 91, and then we just have the x squared put there on the m.